Warm welcome this morning back to our presentations here. Is it too loud?
No, I'm just saying it's very warm.
It is very warm. It's been very warm and it's been beautiful. Absolutely incredible. So Zaragoza is wonderful. I wanted to just set the tone for this presentation. This is intended for a demo section providing to you. What I will do today, though, is actually I'm going to walk through some slides and do a talk through as opposed to a demo of the Windows Server products that are involved in this cloud infrastructure. However, please pay attention, and when you receive the handouts, there is an appendix of a number of resources from our most recent presentations, including Ignite, which record, in fact, some good demonstrations of the topics that I'm going to cover. Have all of you heard about the fact that Windows 10 is releasing here very soon? I'm not so concerned about dates since I'm not in marketing. However, have you also heard about Windows Server v Next and the cadence, which will not release this year, but we will continue on a quarterly cadence of providing previews, which the one was just published here in April. And this roughly quarterly process will continue in roughly, again, I don't care about the dates as I'm not in marketing, but roughly the year proceeding to finish the Server v Next. Now, most of you who are in the protocol world, such as Chris, are familiar with our protocol specifications, which we are in sync. All of our open specifications, to the references I provided to you in yesterday's presentation, those preview specifications that I mentioned are in sync with the vNext server preview, which just came out for Ignite in April. So, and we will continue that process if there are changes to the protocols. And they are always subject to change, although as you gathered from my presentation yesterday, that the SMB 311 dialect is relatively complete at this point. So I wanted to just set that clarification. Any questions about the cadence of Server v Next that you'd like to ask in general? Great. Okay. I just wanted to make sure you were all aware of that. So again, for today's session, our goal is to talk a little bit about Server v.next. This presentation will be a little more focused from the interoperability side. I'll make sure to point out where our foundations of the SMB 2 and 3 protocols that have been developed, and you'll see how all of the things that are so familiar to you in this world of the storage protocols, they have really become integrated into what we're calling this Server v.next in this software-defined storage as it's described in the industry now. I would also like to explain to you just a little bit about how the Microsoft pieces of this puzzle fit together as we build the private cloud, partners out there building that private cloud and serving the various data functionality for all of these open systems, whether it be servicing a Linux client or others. The concept of the hybrid cloud, which, and finally, of course, as Julian and others mentioned, this idea of using a public cloud with Office 365 or Azure. So the software-defined storage is an offering which will be based in the Windows Server v.next itself, but can be used to construct these cloud architectures from private to hybrid and public. Some of the trends that were talked about yesterday, the big ones in the data area, as Julian pointed out, becoming a data programming wizard is going to be incredibly important. The explosion of data that we're dealing with devices, big data, the modern apps that are being utilized to expose that data in a meaningful way to our users, the cloud scale services that are being provided to serve this that all of us are so familiar with, whether it be Facebook and Google and some of the Microsoft cloud services. Virtualization, which is ubiquitous now, the scale that we're seeing across these systems with highly dense cores. No longer are we seeing massive numbers of systems necessarily, but the density of these systems with the cores is going up higher and higher, and then the virtualization gives this ability to provide compute density and storage and software and networking as well. The challenge, though, at the other end of the graph, which the scale out with minimal operation complexity, is really at odds with this concept of scaling out. Typically, when we scale out across multiple systems for various reasons, there becomes a problem with management. And we certainly I can say that certainly Microsoft has learned about that in recent experiences, that simplifying that is going to be incredibly important. And you may have heard of some of the efforts that are going on in the OpenStack world to deal with such things on a grand scale as well, with many, many big projects at work. So these are some of the areas that are really impacting this. And so when we have software-defined storage, we want to have a cloud scale, but we want to maintain economies. And so you're hearing about that in the industry, that this economy, the cheap hardware and scaling out, these two dynamics are coming into play in a big way. So what Microsoft has learned, as I alluded to, there certainly have been a lot of learnings. Long ago, when I first came to Microsoft, we had something we called dog fooding. And in those days, you sat down and you ran email, and you ate that email or ran against the Windows NT server, debugged it running our customer services database that those of us worked on. We helped debug problems. So we ate our own dog food. Well, the scale now has increased. But the concept is still much the same. Microsoft, all of us, we're eating our email dog food on Office 365 now. For those of you who've been on conference calls with us with Link, generally quite nice. Actually, I have to clarify, it is now Skype for Business. So the dog food is yet again experienced on a day-to-day basis. And generally that's very good. Sometimes when it's a new release, there can be difficult experiences. As we alluded to yesterday, the Azure services were built on Windows experiences, but you'll not always see exactly the same one-for-one correlation of functionality. And you want to, for example, with Azure Files, as we mentioned, refer to the documents for how those features actually are supported. But the concept, again, using Windows to run some of these cloud properties, and then in turn taking the learnings from the cloud properties back into Windows. And I'll explain a little bit more about what we learned from these experiences. One of the things that we're talking about today is software-defined storage. But as you see here, there's three pieces. There's the software-defined computing, software-defined storage, and networking, which is being implemented across the Windows Server pieces. And then on top, you're going to be hosting the VMs, which is, when we talk about interoperability from the platform side, be it Linux, which all of you are very familiar with, so those Linux VMs, and providing that hosting environment that is giving a first-class environment to Linux, which we talked about before, how important it is to contribute to that project, even from Microsoft's standpoint. So all of those OSs are hosted well, and in particular Linux is first class, along with Windows and the others. So underneath all of this, to build this, are these three pillars of the software-defined computing, networking, and storage. So I just wanted to lay out that concept as we really will focus just a little bit more on software-defined storage. So the software-defined storage journey, for those of you who have been in the Microsoft world, you're a bit familiar with the Windows Server 2002 R2 systems, and as they developed. This really began in that world when we have at the foundation a bunch of disks that are connected often in the server world in SAS in the past, which was a bit more of a high-cost environment. We'll talk about what's happening in today's world where costs are driving down much further. You end up with your scale-out file server clusters. Again, one of the key concepts that Volker described, of course, and Chris in the world of Samba, very, very well aware that that next step up, you need to have that the clustered file server world in the SMB2 and 3 storage world. This SMB3 file share concept became critical, and so when you're dealing with this world, you have to have clustering for continuous availability. And this continuous availability becomes a requirement, as we've talked about, for the Hyper-V world, so for virtualization. So, and that'll be true for any implementation, not just Windows. So these concepts in SMB2 and 3, you'll see interwoven throughout, and you'll continue to see this theme repeated in this discussion. Although I'm providing a picture into what Windows Server v.next is providing, you can well imagine the key pieces of SMB2 and 3 as they apply here very much apply, as we heard in yesterday's presentations, to not just Windows, but throughout the world, including Linux. Okay. And in the Microsoft world, when we talk about, you'll hear the term storage spaces for extrapolating the storage, utilizing those the disk drive resources. Again, performance and scale are critical in this SMB3 file servers network environment, and continuous availability being a key capability that is specified in that specification. So to provide an elastic and efficient storage space, those pools are designed in the world of the Microsoft world with the storage spaces. NTFS was the file system of choice for quite some time. You'll hear about REFS. Now, the key, though, and again, why we're here this week is for the interoperability world of protocols. Windows did include and does include a iSCSI target. In fact, we certainly have that Plugfest participate in the Plugfest at the SNIA SDC. The NFS implementation is included as well for support for an industry standard protocol, and of course our open specifications which describe the SMB2 and 3 protocol implementations for support across the industry. And those support capabilities, be it the transport and failover and continuous availability that we talked about, also include SMB3 Direct, which RDMA is a critical capability as well. And you'll need these capabilities for not only scaling out, but providing performance. And of course, as I mentioned before, those requirements for continuous availability are provided by SMB3 as a service for virtualization, Hyper-V, SQL Server applications at the application level. And this is where we begin to build our private cloud software-defined storage platform that services the application infrastructure that is used to build the private cloud, including Hyper-V and others. So what is new in technical preview? We said we've already got the concept of software-defined storage based on our SMB3 implementations, continuous availability, all of these familiar features that were already provided in SMB2 and 3. So what is new? The quality of service is something that has become very important. We were not as good at providing a consistent quality of service. For example, in Hyper-V or in Azure, we learned that if a VM was running amok and providing, resulting in degrading performance of other VMs, there needed to be a consistency of service. Amazon has talked about this as well, not just Azure. So one of the things that you'll find in our specifications now, particularly at the storage networking layer, we have a new specification. SQoS, the Storage QoS protocol. We'll talk about that in our June event. And so look at that. That's in our previous specification library that I mentioned yesterday. But at all of these levels, starting at the cluster at the bottom, right up through the SMB storage fabric layer, where we do expose this storage QoS at the networking layer, and on up through Hyper-V, you want to enable this quality of service for proper and flexible and customizable management of the VMs and VHDs for fair distribution, and then you can apply policies to that and guarantee some quality of service all the way up at the cloud layer. But just so you're aware that this is being exposed in the network layer as well as a protocol functionality in our open specifications. We had mentioned yesterday about the concept of consistency in the cluster. Versions, there's a requirement of fencing for the protocols to be at a consistent level. And so there's, at the application layer for the scale-out file server in Windows, realization that we needed to build in a concept of a rolling upgrade to get up to the v.next levels and consistently and without providing downtime for the users, and so that those VMs are seamlessly serviced. So this was one consideration, and that really answers that question. Well, how do you deal with the protocol requirement that keeps that cluster in sync at a consistent level of version of the protocol? So this was implemented as a service in order to do that. Just a note that in Azure services, there is a witness for allowing public cloud to be resilient and provide consistent failover in the clustering and monitoring, similar to what we've seen in the witness service. There's a witness that we mentioned before to contracts. That witness service is at the protocol layer for SMB2 and 3 implementation at the protocol level for your failover. So this is just a note that is available in the Azure services level as a service in the cloud service. So that is available and a consideration in hybrid cloud versus moving into the public cloud. We mentioned before about this issue of quality of service for VMs. There's also a concept that is very practical of providing resiliency or reliability across a compute cluster of the servers that are serving your VMs, so that if one node falls out of its cluster membership, if there's a network problem or others communication failure, that you remain resilient and transition properly. And this, let's go back, not go quite that fast. You would like to get out of here, but perhaps not quite so quickly. Yeah. Okay, thank you. So having a multiple site cluster, there's also the concept of putting replicas across geographic and other locations, broadly speaking, and providing for some level of end-to-end server disaster recovery. And this type of integrated management and flexibility and scalability is important. So noting that is also critical to building a cloud infrastructure that is reliable. So I've talked about a few things that have been, we've talked about at the beginning what is already here in Server 2012 R2 related to our software-defined storage and things that are familiar to many of us in the SMB 2 and 3 implementations of that in Windows. Then we looked at some of the things that are somewhat new to the preview and what will change in the preview moving forward. There are a few things that we've talked about and with regard to at Ignite and in other recent conferences. So one of the things that I mentioned to you before was this issue of drive cost. And in the past, as I said, in 2012 R2 timeframe, we were dealing with a world where there were a lot of SAS drives. Have many of you heard about Amazon and Facebook and these? For example, Facebook came out with this, and we'll mention this in the compute piece later, but right now let's just talk about the drives. Have many of you heard that not so much SAS anymore, but they're just looking at just a bunch of drives and using the cheapest level of communication. Have you heard that statement? That this is what is, costs are being driven down to the lowest level at the drive levels. And don't even bother with SAS anymore. So for servers. So in the data center, we're seeing, this is what we're seeing. So part of the concept was customers or data centers were asking, we don't need to share a SAN or some high-end storage space anymore. We'll just build it with a bunch of cheap or very inexpensive mass manufactured drives, which we're seeing. So have many of you heard that request? Yes, Chris, yes, others. So it's true, yeah. Thanks, CMO. So that's what we're seeing. And so as a result of that, you'll hear something that Microsoft is saying, well, software-defined storage, sharing nothing in the storage. So we simply, in the cluster, scale-out cluster at the bottom, we're going to be referring to those drives without sharing at that level. And then exposing that up to the Hyper-V cluster level or up for Azure in its world of virtualization as well. And again, using this with cheap SATA drives.
This is the model, that for example, Gluster uses that your storage is in an intelligent brick, and then the brick is part of the cluster, and you don't care about the storage being part of the cluster.
Right. Thank you, Chris. Actually, do we have the microphone? Yeah, let me. So let's just, is it on? Okay. Say that again, Chris.
I was just mentioning that there are other examples of this architecture. Gluster is the one I've worked with recently, where the idea is that you have an intelligent storage brick, and the brick includes the compute. And it's the compute brick that is part of the cluster, and all the features of that, the storage, the memory, etc., are hidden from you. You don't really care. What you care about is the whole, that's your unit, is that intelligent piece. And that's what you're showing here on your slide, I think.
Right. Thank you, Chris. The voice from above. So yes, and
It's just my stomach from.
Right. So although right here we're not quite jumping into the software-defined compute, but that's from the beginning slide, software-defined compute, software-defined storage. We're defining things with this massively parallel, cheap hardware, whether it's the compute layer or this, in the brick, or this pile of drives. Similar concept, yeah. And we're hearing this from not just Google or Facebook or Amazon, but everybody. As you said, Gluster. I'm sure that this is consistent throughout I'm seeing heads nod in the Linux world. So it's not just a Windows thing, although again, these presentations are filled with what you would see as the Windows world or Microsoft terminologies. These are truly what is happening, a reflection of what the customers are dealing with in the industry. So storage resiliency at cloud scale with standard hardware, again, repeating this concept. We want to preserve tenant sessions for the VMs across this, even if there's a disruption in their environment. If there was some reason that one of the nodes in the cluster, the compute cluster, could not communicate with storage, that it is moved smoothly into a pause state, and then the state can be retained for recovery. So we've talked about software-defined compute very briefly, and thanks, Chris, for that clarification. We've talked about software-defined storage with a little more detail and how it related to all of the capabilities of the SMB 2 and 3 protocols, requirements, and continuous availability that are defined, and resilience and failover. But in a similar fashion, Microsoft found that in order to build the cloud, and this is again probably something that is consistent in your experiences in building the clouds, whether it be in any other open environment, OpenStack, all of your experiences with Linux, that the network stack is critical. So to be perfectly honest, one of the things we found is we had to redesign this networking stack. And you'll notice in Server v.next, in fact, there is a new network stack along with a new storage stack. So it's quite a bit of change in the Windows Server that you'll be observing. And a lot of that, again, is due to this continuous improvement cycle we were talking about, of using it to build a cloud and scale up to higher levels. What do you find out? Well, we find that the offloading and high-end network performance are critical to keeping your CPU utilization low. And things like, you may have heard our RDMA work, right? One of the SMB3 capabilities, direct memory access, RDMA. Well, it's very high-end. You've got options, whether it's InfiniBand or others, at the high-end Ethernet levels, FCOE. Those protocols are very valid, but even in Windows Server 2012 R2, we were not virtualizing that. So you couldn't share it if you were someone like myself setting up a test environment to host an event. We could not virtualize the RDMA layer. Well, now, this is one of the new things that you can virtualize, so you can take advantage of those 40 gigs, or maybe in the future we're hearing, right, 100? Is that what we're hearing even at the Ethernet? So not just InfiniBand, but we're seeing very high-end networking capabilities that can be virtualized and taken advantage of. So also that brings the issue of network reliability that is so critical from these implementers. The other thing is the open protocols for the switch layers, whether it's the Open vSwitch database layer and other protocols. Oh, and the network virtualization for generic routing. Some of those protocols that are implemented at the network provider layer and lower level switch and routing layers are very important to the virtual network layer. So there's a need for managing this process, and the network management now has also been revisited. There are some industry standard interfaces, REST APIs, that are consistently exposed. You'll hear about the REST APIs being exposed throughout. Microsoft is certainly also committed to working with those. You've heard it in some of the other presentations this week, that whether it's in the Office 365 world or Exchange protocol world, that those REST APIs are critical. It is in fact the case at the basic network and network management layers as well. So that is important for the management and diagnostics. The virtualized network functions are certainly important. We've certainly seen a lot of requests for virtualized appliances in the world of whether it be in our cloud requests. So have some of you started seeing these converged, hyper-converged virtualized Linux appliances for storage? Are those some of the things that you've been hearing, Chris? Yeah. Yeah, well, we're certainly beginning to get those requests, be it in Azure or other places. So customers are certainly requesting that. This is one of the other areas that this software-defined networking in vNext was a critical component to be interoperable and supportive of these virtualized appliances, and in particular, as we're discussing some of the Linux ones that are being implemented. And at cloud scale IP address management, there are also, of course, the standard protocols for IPAM and DNS, which is fundamental to the infrastructure. There were some additional capabilities for security that were added in a distributed firewall. But let's suffice it to say, in wrapping up on the virtualized network layer, that the software-defined network layer was something that was learned to be very important in the data center, along with the software-defined storage. So again, you'll see a new stack for this as a result that was needed to handle that performance. Essentially, some of the older stacks were simply falling over, had reached their limits. They didn't have adequate virtualization. They weren't able to virtualize the newer protocols, and they simply were not sufficient for scaling across the kinds of highly scalable multiple network paths that are now available. So that was one learning that was in fact taking place. So one of the things that I wanted to talk about briefly, we tiered storage. So this is something that's becoming very standard. The concept that you would want to have your data in your data center and then also be able to put some of it in the cloud for a tier that would be perhaps less of it would be for archiving or other purposes. There's something from Microsoft that had adopted the Store Simple, and it was an acquisition. Have you heard of Store Simple? Yeah, Jack. Well, you better have. Store Simple, basically on the network, simply looks like another iSCSI LUN to your system. So it's not. It's a very simplistic concept. In the back end, it is in fact going to the Azure cloud. So it's going up to Azure. But for IT purposes, it simply looks like another iSCSI device. That's all it is. And I suspect that this is not something that's all that unfamiliar to you in your storage world, that there's a need for a tiered space in whether it be iSCSI or using some other methodology of communication. You're going to want to have a tier storing into the cloud. So that is what Microsoft did for that implementation. And having an on-premise Hyper-V cluster is certainly understood. That Windows Server does support Hyper-V, of course, and then also those VMs can be moved to a cloud. So whether you're, and this really brings us back to where we started at the beginning, which is with Windows Server, whether you're supporting a Linux VM in your IT environment, so we want to have a Linux or Windows VM, it doesn't matter, but if you're supporting that in your IT environment, locally, on-premise, that's fine, but what if you want to store that into a private cloud? The service provider could service that, or you wanted to simply have it in the public cloud. And to be honest, Microsoft, well, sure, we'd love to have the Microsoft company would love to have everything up in Office 365. Azure, that's great. Not going to happen. There's a lot of countries and companies, governments, security requirements, and privacy requirements dictate that much of the data must be at a private cloud, either in an IT environment, perhaps, again, like we talked about with a hoster, in a hybrid cloud environment. Some of the data may be able to be there. And then, in fact, in a public cloud environment. So fully realize that all of these are considerations in this modern world. And I think this will be an evolving concept. But you'll hear in these references that I'll give you that there's a concept that Microsoft is committed to a consistent cloud experience for the customers. So from an interoperability standpoint, as you saw, the software-defined storage in particular has a lot of capabilities. But at its basic foundation, many of the concepts that we've seen over the last 3 to 5 years talked about in the SMB 2 and 3 protocols and at SNIA and other storage developer conference experiences, as well as the other protocol events, this is something that has become a foundation and a requirement, in fact, for what we're saying is in Microsoft Server v.next, and what it appears to be, as we've talked about, an industry phenomenon requiring these software-defined layers to drive this forward and manage it effectively. So, questions? Yes, Chris. We have the microphone. Try. All right.
This is a very quick and is that on?
Yes.
Oh, okay. It's a very quick and selfish question. You're going to repeat this presentation either at Samba XP next week or at the event in Redmond next month?
Good question, Chris. So not planning to so much at Samba XP, although I think what Tom Talpe's intention is more to provide. This was again more of an overview. This is far more of an overview. Okay, good. I'm glad it was helpful. I'm trying to. The whole purpose of this was to bridge the world of some of the Microsoft specific language back to what is industry standards and protocols that you're familiar with. Tom will be speaking specifically about some of the things he wants you to hear about on the SMB3 side, Tom Talpe. In Redmond, we will have a series of presentations. We'll dig a little deeper into the software-defined storage at several levels. So we'll have several presentations in June targeted at it. Oh, and please do, for the purpose of the appendix that will be included in the handouts, but for those of you who don't have the appendix, for the recording, Channel 9, msdn.com/ignite/2015. You'll be able to get a whole series of presentations on Windows Server vNext, including the storage presentations by Jose Barreto. He's blogged about some of this issue as well. These are storage areas. So, any other questions before we wrap up? Thank you.